Hello 3D printing friends! Today on the BV3D channel we'll take a look at the Longer LK5 Pro 3D printer. Stick around and we'll get into it right after this. I'm Brian and you are watching BV3D. Hi, welcome back. Hey, if you're new here and you're wanting to learn about 3D printing, 3D modeling, and other 3D printing related stuff, start now by subscribing and clicking the bell so you don't miss anything. Okay, so today we are taking a look at the Longer LK5 Pro 3D printer. Longer sent this to me a few months ago, thank you Longer, and I finally got a chance to start using it. I've printed small things on it, I've printed medium-sized things on it, and I have printed absurdly large things on it. Somewhere in the middle of all that printing, I printed a couple of upgrades for it too. Actually, it was closer to the beginning of all that printing. Anyway, one of them is an absolute necessity, while the others make the printer just a little more enjoyable to use. And we'll talk about those things a little bit later. But first, let's go over what comes in the box when you get the printer. Obviously, the printer is in there, separated into a couple of easy-to-assemble modules. There's a power cord, and there's a micro SD card with a USB card reader. The card contains a few pre-sliced G-code files, a quick video showing how to assemble the printer, and an installer for the Longer 3D Slicer, which is a Windows-only version of Cura that only has profiles for Longer 3D printers. Also included are zip ties, hex keys, a wrench for the nozzle, and eccentric nut adjustments, and a distinct lack of flush cutters. Seriously, what is up with printer manufacturers not including flush cutters anymore? This is like the third or fourth one in a row. The printer is pretty easy to assemble, and there's both a printed assembly guide and a video assembly guide. The process is basically this. Remove the printer from the box, slide the X arm onto the Z gantry, bolt the Z gantry to the base, bolt on the Z braces, bolt on the screen, plug in the wires, don't worry, they're all labeled to indicate where they go. Set the input voltage switch on the power supply and you're done. Well, somewhere in there, you have to bolt the Z-axis stepper motor onto the gantry and install the Z-axis lead screw, but you get the idea. Yes, it's a little more involved than a fully assembled printer, but it is significantly less involved than assembling, say, an Ender 3. Well, now let's talk about the LK5 Pro's specs. The Longer LK5 Pro has an 8-bit mainboard with silent stepper motor drivers on the X, Y, and Z axes. It has a color LCD touchscreen in portrait orientation. It's got a build volume of 300 millimeters on the X-axis by 300 millimeters on the Y-axis by 400 millimeters on the Z-axis. It has a Bowden drive extruder feeding a PTFE-lined hot end terminating in a 0.4 millimeter nozzle. The nozzle can be set to a maximum temperature of 250 degrees Celsius. It has a filament runout sensor, so it can let you know when you need to run out and get more filament. Sorry, I can't not make that joke. It has Z-axis bracing to help prevent the Z-gantry from wobbling since it's so freaking tall. It has a V-slot aluminum frame with closed faces on the user-facing parts, which gives it a slightly less industrial look, but it's still pretty industrial looking with the power supply kind of in the open under the right-hand side of the printer. It has an assisted leveling feature to help you manually level the bed, and that bed is one of the textured glass types that holds onto the printed model when it's hot and generally releases when it's cold. That glass bed is held onto the aluminum build plate with binder clips, and the springs which support the build plate are those good yellow ones that I like. And the bed can be set to a maximum temperature of 100 degrees Celsius. It's also got a lot of metal on it where other printers might use injection molded plastic. The cover over the X-axis pulley, which holds the X-axis end stop switch, is metal. The hot end fan shroud is metal. And the LCD screen bezel and its back cover are metal. Combined with the Z braces, all that metal gives the printer a solid, sturdy feel. Now that we've got the specs out of the way and we've seen the outside of the printer, I wanted to get a look at the electronics enclosure to check out the wiring and also take a look at the mainboard. So the internal wiring looks pretty good. The power input connection and the bed power output connection on the mainboard use a connector that I recognize as a Dean's connector from my radio control hobby days. I think this is also known as a T connector. Anyway, the connections on them look solid. Taking a look at the nozzle heater connection, this is on a removable plug with screw terminals. And unfortunately, the ends of these wires are tinned. So I've snipped off the tinned ends and replaced them with wire ferrules to improve the connection and reduce the chance of this connector overheating and causing problems in the future. The cable bundle for the X-axis and the printhead are secured with a zip tie where they leave the electronics enclosure, providing at least some strain relief. But the cables going to the bed don't have any strain relief. Without strain relief, a good pull on this cable can put a lot of stress on the bed's power connection. So here, I added a zip tie through the vents at the back of the enclosure to help secure the cable. The power supply is a 24-volt unit, and the connections to it are crimped fork terminals. Also, the connectors on the mains power input and on the power switch have insulating boots on them. Overall, I'd say the wiring in the electronics enclosure is pretty good. The only things requiring my attention were the nozzle heater leads needing ferrules and needing some strain relief for the bed wiring cable that exits the enclosure. So now that we've looked at the wiring, let's take a closer look at the main board. The microcontroller is an Atmega 2560, so this is an 8-bit board and it uses socketed stepper motor drivers. On most inexpensive printers, the driver chips are soldered directly to the main board, and therefore the only way to replace a failed driver is to replace the entire board. So in theory, having the stepper drivers on removable boards plugged into sockets on the main board improves repairability in the event you need to replace one of these drivers. There are a number of unused ports on this board, and Longer has the source code available on their GitHub repository, so if you were inclined to use those ports for something else, the code is there for the tinkering. The enclosure itself is pretty roomy. There's space to mount a Raspberry Pi in here if you wanted to, or you could mount some buck converters to provide something other than 24 volts for accessories. Maybe you need 12 volts for a quiet fan, or you need 5 volts for a Raspberry Pi or a USB lighting solution. Just remember that any modifications you make to a printer are done at your own risk. So what about actually using the printer? Well, that's actually pretty easy too, thanks to that touchscreen. It's bright and responsive, and the UI takes advantage of the color. There are a set of buttons across the bottom to take you to different pages of commands. The home page is the page you start out on, and it shows the nozzle and bed temperatures, as well as the name of the file being printed, how much time has elapsed, printing progress, etc. The tune page lets you adjust the nozzle and bed temperatures, the part's cooling fan speed, printing speed, and the flow rate. The Move page lets you move the X, Y, and Z axes. The Utilities page has buttons for filament and leveling. The Leveling button brings up the assisted manual leveling screen, in which the printer lets you move the nozzle to each corner and to the middle of the bed to adjust the leveling knobs. I like heating the bed to working temperature before I adjust it, but that won't work on the LK5 Pro. Even if the bed is hot, when you use the leveling feature, the printer sets the bed temperature to 0 and it starts to cool down. So in this case, leveling the bed at room temperature will give you a better result, and then you can fine-tune the knobs during an actual print to get them dialed in. The filament button brings up a screen with load and unload buttons. Choosing either load or unload will heat the nozzle for you first. Unloading the filament pulls it all the way back to the extruder stepper motor, and it moves quickly. Loading filament moves slowly, so I think it expects that you've manually inserted the filament all the way to the nozzle, and it keeps moving slowly until you tap OK on the screen to stop it. And lastly, there's the Print page, which has one button, Files. This lets you select a file for printing. File selection is somewhat limited, however. The printer will only show you 5 pages of 5 files each. And it doesn't show you the 25 most recent files either, so if you have more than 25 files on the card, some of those files will not be shown. So with that limitation in mind, keep 25 or fewer files on the card and you'll be fine. Also, just to note, the printer doesn't allow navigation into folders on the card. Some printers do, some don't, and this one don't. So using the printer once it's built is pretty much a matter of turning it on, loading filament, and selecting a file to print. There are a few files already on the card that you can print, so you can confirm that the printer is actually working. I do recommend using an actual spool of filament and not relying on the tiny sample of filament that comes with the printer. Although I didn't try, I don't think it's enough to really print much of anything. I did test the filament runout sensor, and that works as expected. The printer paused and let me load up more to continue printing. I also tested the power loss recovery feature, and while I thought it was working as expected, That turned out not to be the case. I turned the printer off partway through a print. When the printer was powered up again, it asked if I wanted to resume the print. I chose to do so, and the printer brought the bed and the nozzle back up to temperature. It homed the X and Y axes, and then moved the nozzle back over to the partial print, and it started printing again. Or so I thought. At first it looked like it was working, but then I looked over a little while later, and it was just being a little weirdo. The extruder stepper motor was moving just fine for retraction and de-retraction moves, but for regular extrusion moves, it was just sitting still or twitching a little. Even when holding the tensioning arm on the extruder, thus releasing pressure on the filament, the motor would move just fine for retraction and de-retraction, but just twitch a little for regular moves. For all intents and purposes, the printer has simply stopped extruding, and of course the print failed, so I have no idea what was up with that. Turning off the printer, removing the failed print, and starting the print over worked fine, and the printer completed the print job without an issue. To me, power loss recovery is one of those features you think would be super handy, but I find it best not to depend on it. When it works correctly, it's pretty neat, but it depends on the print surface your printer is equipped with. The Longer LK5 Pro has a glass bed that releases when it cools down. If the time between the start of the power outage and the time that you're able to resume the print is more than maybe 10 minutes, the bed will cool down, it'll release the print, and so trying to start it up again may just result in the print being dragged around the bed by the nozzle. Okay, now that we've gotten a look at the printer inside and out and gone over some of the features, let's take a look at some of the things that I've printed. Way back at the beginning of the video, I mentioned one print, an upgrade that's an absolute requirement, and that's this: a bed cable strain relief for the end of the cable that connects to the bed. The reason it's necessary is that there's literally nothing to support the end of the cable coming off the bed except for that connector. Without support, there can be some stress on the wires where they go into the connector, and there's going to be some stress on the connector itself. So this upgrade supports the cable and the connector. It's almost exactly like the one on the bed for an Ender 3 series printer. And installing it was easy. I removed the binder clips securing the glass bed to the aluminum and set the glass aside. Then I removed the two adjustment knobs at the back of the aluminum plate. That allowed me to lift the screw up a little bit from the plate at the corner where the connector plugs in and slide the strain relief in between the spring and the Y carriage. Then I put the screw through the strain relief and the Y carriage and put the rear adjustment knobs back on the printer. Since this printed strain relief doesn't actually touch the bed, the temperature of the bed shouldn't be a problem at PLA and PETG temperatures. I printed it out of PLA, and it's been fine through probably 100 hours of printing so far. Anyway, with the strain relief installed, I used a couple of the included zip ties to secure the bed's cable to the strain relief, and that was it. Well, that was almost it. I did have to level the bed again. Tram the bed. Tramming is the more technically correct term. Scott Latine, the curator of the Marlin firmware project, is planning on replacing the term leveling with the term tramming every place that term appears in Marlin, so we probably need to start getting used to saying it. Okay, so the next thing I printed that's kind of necessary was another length of that V-slot cover that I printed to secure the wiring for the halo on my Ender 3 V2 recently. You know, this kind of thing. While I did need some to secure the wiring of this halo, and this one, by the way, is an 8-inch ring light, the other thing I needed it for was to secure the wire that goes from the electronics enclosure at the back of the printer to the screen up at the front. Otherwise, that little wire is just hanging down, begging to get snagged on something. So I used a few little segments of it to clip the wire into the underside of the extrusion that runs from the front to the back here on this side of the printer. What else did I print? Well, I printed the clips to hold the halo up at the top of the printer. So the bed cable strain relief and the cable clip for the screen, to me, those are 100% necessary. The halo, well, it's not necessary, but it's what I consider a quality of life improvement. It's the kind of thing that makes a printer just a little nicer to use. Another quality of life improvement that I printed was this pair of bins that just snap onto the front of the printer. There's a catch on the back of them that hooks into the slot on the extrusion, and then gravity does the rest. The catch is from the Creality Ender 3 V-slot tool holder tray by Thingiverse user Danny W281. Their bin wasn't what I had in mind, but I liked the way it worked. So I designed a new bin, but used that catch. I designed the bin to fill the space between the frame and the front of the printer, and I also set its width so that it didn't go underneath the extrusion that the Y carriage runs on. That means if you print two of them and mount them at the front like I did here, there's a gap between them. If the aesthetics of that bothers you, just scale them a little bit wider when you print them so they fit together evenly. The bin will also fit nicely on either side of the printer, so if you don't want it on the front, you can park it behind the screen instead. I like these because they provide a handy place to park tools, such as the wrench or the hex keys that come with the printer or the flush cutters that don't come with the printer. Or they can be used as a little dumpster for priming lines and skirts and whatnot. Okay, so continuing on, some of what I printed was calibration prints, which I did when I was trying to get some settings dialed in. Longer includes a version of Cura that has their printers defined in it, but it's Windows only. Since I don't run Windows, I couldn't make use of it. But Cura has downloads available for Windows, Mac, and Linux, so I have the Mac version of Cura 4.10 installed, and that's the current edition. And Cura 4.10 has a printer profile for the Longer LK5 Pro, so it's not that big a deal that Longer includes Windows-only software. And Cura's LK5 Pro profile works pretty well. But I'm more familiar with Prusa Slicer than with Cura simply because I use Prusa Slicer all the time. So even though Prusa Slicer doesn't have a profile for this printer, I just duplicated one of my Ender 3 profiles and adjusted it to match the build volume of the LK5 Pro. I printed a few retraction towers sliced with Cura and a few sliced with Prusa Slicer, as I was getting the retraction settings dialed in with Prusa Slicer. Cura was my control group, so I had something to try to match. So there's a bunch of retraction towers. What's next? Calicats. One of the things about the LK5 Pro is that the parts cooling seems to leave something to be desired. It's got a 4010 fan pushing air into a duct to blow across the print, but it just doesn't seem to push enough air to do the job. When I printed these Calicats, I could tell something was up because the 45-degree overhang on the tail wasn't looking good at all. That part of the tail was on the side of the model opposite the direction the fan was blowing. When I rotated the model 180 degrees so that the tail's 45-degree overhang was being directly blown on by the fan, it came out much better. So that tells me that the cooling is just a little bit insufficient. A 45-degree overhang should be well within the capability of any current printer. I printed a few CHEP cubes, and they all came out really good. I have no complaints about those. I also printed a couple of 3D benchies, and these all came out pretty good. This one in black I printed at something like 0.12 millimeter layer heights just to see how it would come out. Literally everything else that I'm showing I printed at 0.2 millimeter layer heights. This one at 0.12 came out really great, except I think this was before I had the retraction set right, so there's some significant stringing inside the wheelhouse. And the parts cooling issue cropped up again. This rough patch on the bow of the benchy is from those layers curling up just a little bit during the print. But apart from the stringing and that little rough patch on the bow, this came out really good. Moving away from calibration prints, I have a little screw top container that I found on Thingiverse. It's designed to use the plastic lid from a Coke bottle, but they also included a printable lid. There were several types available in the download, but I liked the knurled one, and it came with a matching lid, so I printed that too. This came out fine, and the threading works great. I have zero complaints about this print. I printed the parts for a recent Alien 3D UFO Mystery Box project, which is a teeny tiny arcade game. Those parts came out mostly fine. Some of the layers are a little irregular down near the bottom, but that may have to do with the geometry of this model. There's a lot going on here where the buttons are supposed to go. Anyway, I just need to assemble the electronics and then I'll be able to play. Let's see, what else do I have? I have a phone stand from PrusaPrinters.org. This is a model I really like. The hexagons are interesting to me. It prints on its side, and I thought it would look cool to turn off the top and the bottom layers and use honeycomb infill, so you could see the hexagonal pattern carried through the entire model. While these settings did leave a gap in the circular opening here, that's not the printer's fault. It did what the slicer told it to do. Given that, I think it came out great. Next, I have Luby3D's Aria Dragon printed at 100% size. This was sliced with Cura, and while there's a little bit of stringing, it's nothing really bad. Overall, it turned out pretty good. Getting into some larger prints, I scaled Aria up to 200% size, and I wanted to see if there was a big difference between slicing it with Cura and with Prusa Slicer. Turns out there's not a super huge difference. The underside of the chest on the Prusa Slicer one is a little bit rougher than the Cura one, but the Cura one has a loop of filament hanging down from the pedestal. They both have a little bit of stringing, but this is very minimal. Printing time on both of these was just a little over 10 hours, with the Prusa Slicer one finishing at 10 hours 11 minutes and the Cura one finishing at 10 hours 5 minutes. Next up is the Reciprocal Vase by designer Clockspring. I adore this model because it has such a huge amount of visual interest. There are these big wide ribbons winding around one direction and these smaller ones inside winding around in the opposite direction, and I just love it. Anyway, zero issues on this print. Now I saved the largest for last, and that's this faceted rose vase. This used the full build height of the LK5 Pro. It is a whopping 400 millimeters tall. It too came out just fine, and I don't see any issues with the print quality. Oh, and by the way, all this orange, that's all Printed Solids Jessie PLA in Mystery Orange. It's rich in retina-burning goodness, and it really prints well. I'm pretty sure I know someone who would approve. #TeamOrange. Okay, so I think it's about time to start wrapping things up. Here's what I think of the Longer LK5 Pro, starting with the good. Thermal safety is enabled and working. I tested the thermal runaway protection feature for both the nozzle and the bed. First, while the nozzle was happily holding steady at 200 degrees Celsius, I unplugged the heater cartridges connector from the main board. The nozzle's temperature started dropping, and after a minute or two, the printer displayed a thermal runaway error on the screen. After power cycling the printer, I did the same test on the bed, unplugging the bed's power while it was holding steady at 60 degrees Celsius. As expected, the temperature dropped, and after a minute or so, the screen displayed the thermal runaway error again. So hooray for thermal protection! Also, the LK5 Pro is a pretty good value. When I started working on this video, it was priced at US $339. Now it's US $319. For your money, you get a larger format printer with a generous 300 by 300 by 400 millimeter build volume with Z-bracing to keep the frame from flexing, and the whole thing feels super sturdy. It's easy to assemble. There's a pretty good assembly video on the micro SD card that comes with the printer, and the printed guide covers the basics of assembly too. It also covers installing the Windows-only Longer slicing software and tramming the bed. The touchscreen is nice, and the user interface is reasonably well laid out. And the large, textured glass bed is nice and flat. It's been working flawlessly, holding prints when hot and releasing when cool. Overall, I think the print quality is pretty good for a printer in this price range. And the printer's movements are quiet too, with the silent stepper drivers on the X, Y, and Z axes. The extruder uses a non-silent driver, but you can't really hear it. So let's get into the bad things. Although the stepper motors are quiet during a print, the cooling fans are a bit loud. There's a fan on the power supply, a fan for the electronics enclosure, and the fans on the hot end. It's not horrible, but you're not going to be snuggling up next to it for a nap with your teddy dog thing. Parts cooling is not the best. It doesn't affect every print, as evidenced by the fact that most of the things that I printed came out just fine. But Calicat tails are, for some reason, particularly sensitive about it. Fortunately, this can be addressed to some degree by changing the orientation of the model when printing it. I think changing from this fan to a 50-15 blower would work better, and I bet with a little bit of searching I can find a printable mount for one. While the filament runout sensor works fine, I wasn't happy about the weird failure of the power loss recovery feature, where the extruder would only perform retractions and de-retractions, but otherwise wouldn't push filament to the nozzle, which caused a print to fail. Electrically, I wasn't happy about the nozzle heater wires being pinned with solder and clamped in the terminal block. That kind of connection can loosen over time because the solder gets deformed by the clamping force. And that connection getting loose isn't just an inconveniently intermittent connection. That looseness means it'll have more electrical resistance, and due to the amount of current flowing through it, it'll heat up. On a different printer, I had a similar connector get so hot it melted its plastic housing and cooked part of the printer's mainboard. So I added ferrules to the LK5 Pro's heater nozzle wires, which will provide a more solid connection. There was also a lack of strain relief on both sides of the bed cable, but I was able to mitigate that with some zip ties and by printing a strain relief for the cable where it attaches to the bed. Less of an issue was the cable for the printer screen. I was able to clip it to the underside of the extrusion that the screen is mounted on in order to keep the cable out of harm's way. And while the printer's user interface is nice, I did notice it'll only show you a maximum of 25 G-code files. If you've got more than that on your card, the one you want to print may or may not be shown. So, what's the verdict? Well, I gotta admit, I like this printer. It prints tall things, it prints small things, it prints in between things, and its firmware source code is on GitHub, so you can tinker if you have the knowledge and the desire to do so. It's priced reasonably for a printer of this size. Looking at printers with this build volume online, I see some priced lower than the LK5 Pro, but the majority of them are priced higher. Now, there aren't many issues with the printer, but I'd like to see Longer provide the bed cable with a strain relief solution at both ends of the cable, and I'd like to see ferrules on the nozzle heater wires. And I think the parts cooling solution needs to move more air. If this is your first printer, zip tying the bed cable as I did to secure it and printing a strain relief for the bed is a simple matter. The zip ties are included and the strain relief is a few cents worth of filament. The nozzle heater wires, well, using ferrules is safer than tinned wires. That's why I keep pointing out when printers come with tinned ends on these wires instead of ferrules. A ferrule assortment kit with a good square crimper is about 25 bucks. On one hand, that's about the cost of a good spool of filament. On the other hand, that's about the cost of a good spool of filament. I'd rather be able to buy a spool of filament than have to buy a ferrule assortment kit. Longer, if you're watching, I don't know how long it would take to put this into production, but please use ferrules instead of tinning the ends on the nozzle heater wires where they go into that terminal block. Oh, also, flush cutters, please and thank you. So apart from those few things, and to be fair, the tinned wires issue seems pervasive in lower cost 3D printers, the LK5 Pro is a good machine and I've been pretty happy with it. I've got over 100 hours of printing on this machine so far, and I expect to use it a lot longer. You have no idea how hard it has been to not do that through the entire video. Okay, thanks again to Longer for sending this printer over so I could show it to you. If you're interested in purchasing an LK5 Pro directly from them, they have provided a 10% off discount code, and that's down in the description. I'll remove the code when it expires, so if you don't see it, that's why. Well, 3D printing friends, that's about all the time we have for this episode, and now that we're at the end, let's go print something cool. Hey, real quick before you go, I wanted to say thanks for being one of the super awesome people who sticks around all the way to the end, and thanks for all the likes, comments, and shares, and an especially big thanks for those who directly support what I do. You're all wonderful for doing that, and I really appreciate it. If you liked this episode, a thumbs up would be great, and if you'd like to help support the channel, check the description for ways you can do exactly that. And hey, if you haven't already subscribed, please do. It's absolutely free, and it's an excellent way to help keep me making these videos for you. Well, that's it for this one. Thanks again, and I'll see you next time here on the BV3D channel.